that protected against New Orleans against some of the storm surge? Well, the delta has to be nourished. It has to be it tends to erode away, and it has to be renourished. And the way that's done is by silt that comes down the river. Well, what we started doing is we started trapping that silt with dams and levees, and so that silt no longer went all the way out into the Gulf of Mexico and renourished the delta, and so we actually started losing wetlands in the delta and made New Orleans even more vulnerable. The other thing we did is, because New Orleans is a seaport, we thought it would be a lovely idea to eliminate some of the twists and turns in the channel that goes out through the Mississippi Delta, and we straightened those out so that it's easier for the ships to get to New Orleans. But what does that also mean? When I have a storm surge from a hurricane, it goes right up the river to New Orleans. So, and it also means that the sediment shoots straight out into the Gulf of Mexico and not into the Delta. And I'll show you some pictures of the Delta later. So we're losing about 1 million acres of wetlands and barrier islands since 1900, and a significant problem for protecting New Orleans. I love this quote. Mark Twain is a very well-known author in the United States, lived in the 1800s. You may have read some of his books here, Huckleberry Finn, Tom Sawyer. One of his books is called Life on the Mississippi, written in 1874, and it's all about, he grew up living on the Mississippi River and worked on the river boats that were going up and down. Anyway, he made this quote that the military engineers of the Commission, that's the precursor to the Army Corps of Engineers, have taken upon their shoulders the job of making the Mississippi over again, so rebuilding the Mississippi River. And he said, a job transcended in size by only the original job of creating the river. So basically, nature created this huge river, but we're going to do a better job and fix it. So anyway. So for many years, people warned that a Category 4 or 5, the hurricanes have these levels that they assign to them. Katrina was actually only a Category 4 by the time it hit New Orleans. It was 5 when it was still out in the Gulf, but by the time it got to New Orleans, it was down to a Category 4. But they were concerned that it could devastate the coastal region, including New Orleans. So for a long time, we've been worrying about ways to solve the problem. We had something called the Coast 2050 project, which was going to be only $14 billion, so actually not that much, that was going to attempt to do things that would prevent storm surge from hurting New Orleans. And it involved more levees, fixing the barrier islands, huge gates on some of those inlets to the Mississippi. But typical of our attitude, we decided not to do that because the time horizon was so long. I mean, who wants to spend money if it's not going to see a result until, for 50 years? That's not interesting. We want something that will solve the problem tomorrow. Well, not a very good way of thinking. They also proposed a lesser deal, but we're still talking about that one. A $2 billion project, which is really nothing. And by the we've been planning this for a long time, but the hurricane totally changed the geology of the area, so whether it means anything or not. But really, what's a little embarrassing to me is, the Netherlands have put together some great projects to save their cities from storm surge. London, Venice have projects that appear to be moving along, and we're still talking. So anyway, so let's talk historically about how these how we've been protecting New Orleans. Mostly we use earthen levees And some of them we modernize by putting concrete or metal, they're called cap walls or eye walls. I'll show you some pictures of those in a minute. But the problem is that many of these levees are very old. I said 100 years old. Some of them are even older than that. And all we've done is, as the river level has increased, all we did was we just made the levees higher. And when we made the levees higher, we built new levees on old levees. And who knows what's deep down in there. You know, very difficult to figure out what's down there. And so we don't really know how a lot of these old ones were built. Now you can do core samples and find out some information, but we don't know everything we need to know. And New Orleans is, it's really interesting that the level of the river is much higher than the level of the city. If you've ever been to New Orleans, some of you I'm sure have, it's an interesting city. As I said, it's below sea level, but it's really way below river level. And some of the really nice tourist parts of New Orleans, like the French Quarter, are right along the river, and it's a little scary to stand in the French Quarter right next to the river, and you're next to this levee, and you know that the water level is at the top of the levee, and that's like 15 feet above your head. So it's really amazing. You'll see cruise ships, and they're way up here, and you're down here. So it's a very interesting situation in New Orleans. Here's how the levees often work. This is the river over here, and essentially it's just a pile of dirt. And you do this really nice drawing, so it makes it look like a really nicely engineered system. But essentially what it is different layers of dirt and different kinds of dirt, and they compact it, and they do a lot of different things. But there it is. It's a pile of dirt. And that's where the levee is. On the back side of it, they do have a drainage channel, essentially to, there is some water that makes it through here or through the sand or whatever, and so this is used to drain it. You may wonder, if New Orleans is below sea level and well below the level of the river, what happens when it rains? Well, they have a system of pumps all through the city, so all the storm water drains into these storm sewers that have pumps that toss it up into the river and send it down to the Gulf of Mexico. So no electricity, no flood control. You got a problem if the electricity goes out. They have backup diesel generators, etc. If it is a flood, those don't work. So it's interesting. Here's a picture. This is after the hurricane came through, but it shows you what they do. This is a piece of equipment sitting on top of one of these levees, and eventually they decided, well, let's stop making just piling dirt up. And what they did is they built these concrete and steel walls designed to hold the river back a little more. Now, here's some more pictures of the aftermath. Okay, they didn't work. Okay, and what happened is there's a lot of erosion underneath these things and a lot of erosion through the joints. And as you can see, it didn't do its job. Another lovely picture. Here's what's left of some of the. This is right after the hurricane came through, and houses that are flooded out because the levees did not hold. And this is a nice picture. New Orleans has this very complex system where they move water between the river and the lake that's nearby to control water. So if the river level is going up, they send water to Lake Pontchartrain, which eventually empties into the Gulf of Mexico. If Lake Pontchartrain gets high, they sometimes channel it the other way. And so these are canals through the middle of the city designed to prevent or to move water around to prevent flooding of the city. And you'll notice a big chunk of the wall of the canal missing right here. Okay, and all of this is flooded back here. It's not supposed to be. And there's downtown New Orleans there. So huge amounts of the city flooded. And perhaps not surprisingly, What parts of the city flooded the worst? Well, the poorer neighborhoods, the neighborhoods where the less affluent people lived, were the ones that had the most problems, and I guess no surprise there. After this huge problem, after all this flooding in the city of New Orleans, people had to move. I mean, they had to evacuate people to other cities. They evacuated them to Baton Rouge, Louisiana, which is just about 40 miles upriver. They took people to San Antonio, Texas, huge numbers there. We even wound up with a few folks in Albuquerque who were displaced by this. Anyway, afterwards, there was something called the Interagency Performance Evaluation Task Force. Obviously, this is named in a very complicated way, so nobody knows what they are and what they're supposed to do. But they call themselves IPET. The American Society of Civil Engineers did a review of what these guys did. So this was a government program put together to try to see what could be done and what happened and how can we prevent this from happening again. Anyway, so the Civil Engineering Society reviewed their report and basically said a few things that were very interesting. They said that the original design did not reflect engineering judgment that was consistent with what was required for critical structures. So that's very complicated, but basically what it said is a critical structure is one that's very important and essential for the safety of people. And so obviously if it's a critical structure for safety, you must engineer it very carefully. And what they said is that when they originally designed it, they did not take into account the critical nature of this and design with an extra safety factor. Let's see, I'll just hit the highlights here. Oh, I love this one. The ability of any eye wall design in New Orleans to withstand floods is unknown. That's pretty shocking, especially for engineers, to say that, well, we put up all these lovely structures, we spend a lot of money on it, it looks good, but we have no idea whether it'll work. And apparently it didn't. So obviously we did not do a good job on that. And the 17th Street Canal flood wall, which is the one I just showed you, the canal going through the city, was designed too close to the margin for a critical life safety structure. In fact, what they said was that it should have had a much larger factor of safety incorporated into this to make this acceptable. There was also an investigation team put together by the NSF, that is the National Science Foundation, which is a government organization that funds a lot of research at universities in the United States, and a team from the University of California, Berkeley. And anyway, I'll just highlight what they said, and that was the roots of the problems, the failure of the system, were firmly embedded in system flaws. Okay, so what they're really acknowledging is that this was a very complicated system, and there were flaws in the system that were embedded in it, and it had to do with not just the malfunctions of the engineering systems, but failures of organizations and institutions. Okay, so it's a very complicated system controlled by numerous people, and the complexity of it inevitably led